Welcome to this presentation on sketch models. Sketch models typically follow the ideation and iteration stages of design process. As you recall, ideation is the brainstorming stage where we're generating a promising idea. That idea gets developed further through iterative sketching. It's helpful to then create a physical 3D model. Quite often, we make more than one model in order to assess details and proportions and make improvements to our design. While these models are often a little bit rough and made out of a range of different materials, it's important that they're still to correct scale. In order to do that, we have to start by creating a simple orthographic drawing. In this video, I'm going to demonstrate how to move from sketch to physical 3D model. We're going to start with a dining table design. So here I have an orthographic drawing of a simple dining table. You can see I have a plan view, a front and a side elevation. I've based the dimensions on standard dimensions for dining room tables, as well as the proportions I generated through sketching. You can see that I've indicated the critical dimensions of the table at full size. So I have the length and width and thickness of the top, the length and width of the rails, the length and width of the legs, including the taper. In the top right-hand corner, I've indicated my scale, which is 1 to 12. 1 to 4, 1 to 6, and 1 to 8 are also common scales to use in furniture modeling. You would choose the scale based on the complexity of the details in your design and the materials available to you. I've taken the dimensions at full scale and converted them to the size of the parts I'll be making for my sketch model at a 1 to 12 scale. I'm going to start by transferring the measurements of my scale part to the foam core. Because my tabletop thickness at full scale is 3/4 of an inch, I should be using foam core that's 3/32 of an inch thick at a 1 to 12 scale. The closest I can get is 1/8, so that's what I'm going to use. I'll use the straight edge and utility knife to cut the part out. Next, I'll cut the short and long rails out. I'm going to use 1/8 inch thick balsa wood. I'm using my straight edge to guide the utility knife. You'll notice that it's more difficult to cut across the grain, and you'll need to do several passes. Start lightly and then use more force gradually as you cut deeper. When you're cutting with the grain of the balsa wood, you'll notice it's much easier and you'll be able to cut the part free relatively easily. I'm going to cut my parts to width first and cross-cut them to length after. Now I've got my 2 long and 2 short rails. I'll move on to cutting the legs next. Now the legs are 3 by 3 inches at their widest point. That means I should be using balsa wood that's 1/4 inch thick. I don't have that, so I'm going to glue 2 pieces of 1/8 inch together to get that dimension. Now I'm going to cut the tapered leg. I'll transfer the measurements to my material and use a straight edge to cut the part out. This is a bit tricky because the utility knife wants to wander when it cuts diagonally across the grain. Again, start with light passes and gradually increase the force until you release the piece. We can use sandpaper to clean up the part and gradually and subtly alter the taper. So now I have all of my parts. You'll notice that on the bottom of the top, I've laid out lines that indicate where the legs should be placed in the corners. I'm going to use a very small amount of hot glue to attach the parts to the bottom of the tabletop. That way I can remove the parts and make adjustments easily. I'll move my way around the table connecting the legs to the rails as I go. And with the last part going in, the scale model is complete. I can make small adjustments to the legs if they're a little bit crooked. And with the exception of the top, which is slightly thicker than it should be, this sketch model is proportionally correct. Now suppose I want to alter part of this model and change the shape of the leg. Because I haven't used a lot of hot glue, it's easy for me to remove one of those legs. I'm now going to create a tapered cylinder, and I'm going to use paper for that. I'm going to cut a triangular section off the corner of an 8.5 by 11 sheet of paper, start in the corner, and then roll a cone. Depending on the angle that I use when I'm rolling the cone, I can either get a very tapered shape or a more subtly tapered shape. I'm going to use a piece of Scotch tape to secure it so it doesn't unravel. And then what I can do is I can trim the bottom at the dimension that I want for the bottom of the leg, and then I can hold up the leg and match it to the others and trim the top. Okay, so I've got a few different tapered legs that I've created. Some are quite wide at the top, some are a little bit narrower. I'm going to pick the smallest one, and I'm going to use my hot glue gun and secure that leg in the corner. And I'm just remelting some of that glue here to get it nice and flat. I'll place my leg in the proper location, let the glue dry just a little bit, and here we go. So now what we can do is we can compare the round tapered leg to the square tapered leg. We can also experiment with different tapers for both the round and the square leg. If we like the round tapered leg better, we can remove all the square legs and replace them with round tapered legs. The whole idea here is to experiment, to be able to remove parts of the sketch model and replace them with other parts to see what they look like. Let's take a look at a chair now. I've got an orthographic drawing here of a simple chair design. You'll notice that I've also drawn a back elevation so that I can dimension the lower back rail that sits underneath the seat. I've got all of the critical measurements here, and I've also indicated the angle between the seat and the back. As well, I've indicated the radius of the upper crest rail, and I've drawn a rectangular box around the back leg. The back leg is fairly complex. There's a series of angles and flats, and I can use this box to easily figure out the points in space that I need to connect in order to transfer this shape to the material that I'm using to create my sketch model. When making models of chairs, quarter scale is the easiest scale to work at. We can use the materials that we've looked at already, cardboard, foam core, balsa wood, and we would use the same process we did for the table, transferring the measurements of the parts over to the material we're using, cutting it out, and gluing it together with hot glue. To learn how to make a chair model from paper, go to the photo essay titled Instructions for Making a Quarter Scale Chair Model from Paper. Although this method can be time-consuming, you may find that the thicknesses of the foam core or cardboard or balsa are not really working in your favor. So paper might be a more accurate way of working. Remember that these are sketch models. The scale needs to be correct, but they might be a little bit rough looking. Now let's move on to cabinets. You can see that I have my orthographic drawing prepared. I'm going to make this model out of foam core. And I can actually just hold my parts up to the drawing to ensure that they're the correct length and width. There's the top, the bottom, the two gables. Now I've also created a piece that's going to represent the front, and I've drawn the drawer and sliding door divisions onto it. We don't want to actually make moving parts when we're creating a model for a cabinet. As we've done before, we'll use hot glue to connect the parts together. Notice that I'm being particular about which pieces overlap. The top runs long, the gables butt into the top, and they run long at the bottom. Now I'm going to create the base. The base for this cabinet is essentially a simple box, often called a kick. I'm going to cut the parts according to the drawing and then put it together with hot glue as I did with the cabinet. Now I can put the cabinet on top of the base. I'm not going to glue it together because I want to experiment with the setback. As the cabinet comes forward, it seems to float a little bit more, and as it comes back, we can see more of the base. I can also experiment with the divisions on the front with a simple piece of paper. I can play with the different size of drawer and door. Notice that in both iterations, the doors and drawers are inset to the perimeter. And finally, I want to go over how to create curved parts for models. We're going to start with creating curved linear elements. You can see I've made a small form here with radiused corners that I'll be wrapping 1/4-inch plastic rod around. Rod is better to use than tube. Tube tends to kink. I'll need a heat gun. You can be using a blow dryer set on high. It'll just take a little bit longer. And we can see here how this is going to work. The rod will be wrapped around this form to create the design elements that we see. So we're going to position the rod over the form and heat the area that needs to bend. This will take about 30 seconds with a heat gun, longer with a blow dryer. Once it's flexible, which we can see here, we're going to position it and bend it around the corner. Now, if we make a mistake when we're positioning it, we can simply take it off and reheat it until it's soft again, and then reposition it correctly. I'm going to need to hold it in place for about 30 seconds until it cools slightly so that it doesn't spring back. You'll see here that I'm using the heat gun directly over my work surface. I'm in the furniture studio, but you might have to be a bit more careful if you're doing this at home. So I'm continuing to heat the plastic rod where appropriate and wrap it around this form. And you can see that I can change directions and change planes relatively easily, so that I can create a base, a seat, and a back. And finally, when I'm done, I'm going to heat the rod a little bit before I cut it with my utility knife. I find it easier that way. And there we go. A cantilevered chair form out of 1/4-inch plastic rod. Now we'll look at creating curved planar elements. This is task board. It's a low-density wood product that comes in different thicknesses. We'll be using something that resembles the thickness of cardboard. When task board is dampened, it becomes quite flexible. We don't want to put too much water on, but a nice even coating is fine. We're going to put that aside and let it soak in for about a minute. This is a piece that has already been dampened and soaked, and we can see that it's quite a bit more flexible now. I'm going to wrap it around this paint can. This paint can approximates the curve that I want for this piece at scale. You can look around at home for different cylindrical objects to match different radiuses. And I'm going to use the heat gun to dry the piece of task board. Once it's dry, it will keep the curved shape. And we can place this on the chair as a seat. Now this looks a little bit too deep, so I'm going to use my scissors just to trim the depth of this seat. You see that the curve remains even after I've cut it. That looks a little bit better. Now we'll look at creating those curved shapes in foam core and cardboard. With the cardboard, we're going to use a thin blunt tool. I've got a piece of wood, but you could be using a popsicle stick. And I'm going to depress the cardboard in a series of parallel lines that are closely spaced together, parallel to the flutes of the cardboard, which is the natural way cardboard wants to bend. I'm going to crease along those depressions and form the piece of cardboard into a relatively smooth radius. Not quite as neat as the task board, but certainly adequate for a sketch model. We'll do the same thing with the foam core, creating a series of closely spaced parallel lines and pre-creasing along those lines to again create a fairly smooth radius. And we can use our hot glue gun and attach this curved element to the chair frame. I'm just using a bit of hot glue in case I want to remove it. And now that these parts are together, I'm looking at the corners and thinking that they're a bit incongruous with the curves on the frame. So I'm going to trim a small radius onto those corners, and that looks a little bit better. Now when we look at the top surface of the curved foam core, it looks pretty wrinkled. I can just place a piece of paper, the same shape, over top to get that looking a bit smoother. And that's it. In summary, sketch models are different than presentation models. We put them together fairly quickly, so sometimes they can be a bit rough looking, but they are correctly scaled. We can use these sketch models to make changes to proportions and details that will ultimately make the design of our piece stronger.